Good afternoon, everyone, and welcome to the COP28 Cryosphere Pavilion. My name is Pam Pearson. I'm the director of ICCI. We are a proud advisor, actually, to the next presentation, Provide, which focuses on trying to get a better handle on helping countries to prepare for the changes that we cannot prevent going forward, and at the same time provide some reason for mitigation and urgent ambition so that they don't have to in future. Here at COP28, we're very much focused actually on this gradient between 1.5 and 2 degrees. The real difference actually is between 1.5 and today's emissions, what we would say, because emissions have been going up by about 2.5 ppm now for a few decades. They have not paused since the Paris Agreement, and if this continues, we're going to see potentially very high levels, expanding sea level rise, mostly because of collapse of portions of the West Antarctic and perhaps Greenland ice sheet. So you'll hear a little bit more about the potential impacts of these. There are different timelines. This is meant to be a project that is for policymakers to be able to make use of the results, and that makes it very important. And so without further ado, I'll turn it over to Carl to talk more. Thank you.
Yeah, thank you very much, Pam. Good afternoon from my side too, and I can only emphasize how much of a fruitful collaboration that is, and how much we are valuing the collaboration with the International Cryosphere Initiative in this project, both to guide us in terms of what research questions to look at, but also obviously in terms of amplifying the findings that we have and the voice of basically science in this process and beyond. So thank you very much, Pam, and I'll talk a little bit about the risks of a temperature overshoot above 1.5 degrees for the cryosphere based on some of our latest, some of them are even not yet fully out and public results. So some sneak peeks in this presentation for all of you who found your way to us here this afternoon. So I want to start out with the question of keeping 1.5 within reach, and it is certainly still within the cards. That's why we're all here. It's getting obviously more and more difficult by every year that passes where emissions haven't peaked. But we still have ample evidence from the scientific literature that if we reduce stringently emissions in this critical decade, that keeping 1.5 within reach is still very much possible. And just already the first advertisement just today, we published an interactive tool in collaboration with Carbon Brief, allowing you to explore the pathways from the latest IPCC report in terms of what they would mean for the 1.5 degree limit and potential risks of overshoot. So go on the Carbon Brief website, go check it out, and we hope you find this very useful. The thing that I want to highlight in that context is already that if we talk about overshoot and the questions and risks around overshoot, we tend to focus very much on just like kind of a median climate outcome for a certain scenario. But that's not all we need to talk about and not all we need to account for when we want to assess the risks of overshoot, because there's a lot of climate uncertainty around this. So in the real world, it's not a graph like this one that looks pretty much like a narrow band around a straight line. It's more something like this. And this is what we need to discuss and reflect on. And if we discuss overshoot very often, we would say there's a certain level of confidence, overconfidence, I would say, to say, well, look, yeah, we might overshoot 1.5 by 0.2, 0.3 degrees, but then we are going down below by the end of the century. And whether or not we will be able to do this is not just in our hands. It also very strongly depends on how the climate system is going to respond. So a little bit of this framing of, we're going to be in the same outcome or the same place at the end of the century, just in a different way of achieving it, is certainly not what the science is saying. Much more, we need to basically say, look, there's a range of different outcomes that we need to worry about under all these pathways, and we really need to make sure that if we need to peak temperatures as low as possible and then enter a long-term decline. And it doesn't just relate to the question of, we go to 1.5 and then we're all fine. We probably need to see into a long-term decline well below that level, and there are certainly strong messages from the cryosphere coming on that. So the first question was like, if on this overconfidence and overshoot, you tend to think, we're going to be back at 1.5, we're going to be all fine. And it's just going to be a different way to achieve the same outcome. It is not. So research that's basically just about to come out from our project is showing that even for climate impact drivers such as annual temperatures or precipitation, where you think that they actually rather directly respond to changes in the radiative forcing. So if global temperatures go down, you would expect them to go down too. There are significant changes between before and after overshoot in the global distribution of both temperature as well as precipitation. They relate to the complexities of the climate system, which is just not basically a knob that you turn up and down, but there's a lot happening in dynamic responses, being in ocean circulations and others, and atmospheric placement that would lead to very different outcomes in temperature and precipitation before and after overshoot, and something that we need to take and consider very seriously. And then this is the things that we expect to change rather directly. And then there are the irreversible impacts in the cryosphere, from glaciers to polar ice sheets to the permafrost and Arctic sea ice. And that is something that are systems that we know have a long response time, that we know have a legacy and a memory for our pathway trajectories in the climate system, and that actually really require a much closer look. So we did this under this project. This is now for the global for global glacier evolution under Overshoot, and Fabien Masson, who's one of the leading experts on that matter, is with us here today and will provide his perspective on that in a minute. But what you really show there is that there's already a big legacy of past warming for the future of glaciers. So we might lose an additional 30% of global glacier mass just by the basically committed loss that we already have at present levels of warming. And then only limiting warming to 1.5 can actually effectively limit the additional loss to about 10%. On the current trajectory, where we would reach a warming of around 3 degrees, we might lose twice as much as we have already committed, so about 60%. And what you also really see there is that there's a multi-centennial legacy of overshoot. So some of these scenarios towards the bottom, like the light blue, orange, and purple colors, they peak at higher levels, for example, at 2 or 2.5 or 3 degrees of warming, and then try to make up for it in the long run. And what you really see, it doesn't really quite work. So if you overshoot 1.5, there's a irreversible legacy for centuries to come in the cryosphere, in this case, the global glaciers. And obviously, on the global level, this is very concerning, but this is glaciers are really, really important also, obviously, for the regions where they provide water supply and other things. And in particular, that's the case for the Asian water towers. And this is a regionalized analysis, and what it shows is that basically the Asian water towers that are providing fresh water or contributing to fresh water for about 2 billion people as of today have an enormous dependence in terms of their future evolution on the dynamic of overshoot. So the fate of high mountain glaciers in Asia is still very much in our hands. So if we achieve the 1.5 degree target, we can strongly limit the loss of glaciers in this third pole of this planet. Yet if we were to overshoot, we could lose up to 75% of those glaciers, and they are not going to recover on short time scales. So the actual trajectory, every bit of overshoot that we would see matters a lot for this crucial freshwater resource for, probably over the course of the century, almost half of humanity. Moving on to where this water then would land if you lose these glaciers, and obviously not just from glaciers, but as well from ice sheets, as well as the thermospheric sea level rise. We can assess now very robustly what overshoot would imply for global sea level rise, and it's a remarkably linear function. That's not by no means trivial that this is the case. It just happens to be something that we observe. That about 100 years of overshoot very consistently would lock in about 40 centimeters of additional sea level rise. Also there, very much an irreversible signal. And what we find quite striking, so we do conduct this analysis now for different parts of the cryosphere, that this is very similar also for permafrost loss. And also the resulting warming from that loss in terms of methane and CO2 emissions. So also there we do see a clear legacy of overshoot for those systems, and then in this case, their climate feedback. Beyond that, and this is probably directly relevant to some of the discussions that we have here, is obviously just not limiting overshoot, but also this legacy is really relating to what we are doing right now. And this is a study that we've done already a couple of years ago, but it shows every delay in peaking, every 5 years delay in peaking has an irreversible legacy on the cryosphere. And if you pay attention to negotiations, peaking before 2025 is one of the big things that we are discussing here. And indeed, we analyzed pathways that peak between 2020 and 2035. And then looked at their long-term sea level rise output. And it looks like, a very small dip in terms of, or very small difference in terms of what it means for the emission trajectory, yet the global sea level rise trajectory is very, very different. So a 15 years delay would lock in about almost half a meter, or a bit more than half a meter of long-term sea level rise. If this delay now was to cross irreversible thresholds of the cryosphere, this could be several meters just by inaction today. So it underscores why, from a cryosphere perspective, peaking before 2025 is such a central first step. Certainly not sufficient, but absolutely needed in terms of limiting the long-term commitment for sea level rise. Moving on to these questions of irreversible thresholds, and this is a study by Uta Klönne and co-workers. Uta is also with us here today and will provide her perspective on that matter, is that if we need to look at these outcomes, and I started out with, okay, the climate uncertainty is still something we need to take very, very seriously, and that's what you see there. These are three different pathways, basically a Paris Agreement compatible low and no overshoot 1.5 set of pathways, NDC's delayed action pathway that delays action until the 2030s, and then where we're currently heading. And this is the full range of possible temperature outcomes that you need to consider under these scenarios. And they're very wide. And you do see that, in particular, when you delay, even more than 2.5 degrees might be in the cards. And this is very, very significant if we consider the thresholds for the cryosphere as they have been analyzed in the last IPCC report. Obviously, these uncertainties are significant. But what you do see there, in particular, if you focus on the NDC, the middle one, is that if you had higher warming outcomes, you might be in a trajectory where you almost certainly will cross several of the irreversible thresholds of the global cryosphere, just because you get probably a bit of a stronger warming than the best estimate. And this might be enough to really put these systems at very, very severe risk. So looking at this together, what does the messages from the cryosphere mean for emission reduction targets? I think it's a very, very clear signal that also is probably resonating with a lot of people here around the room, how 1.5 is such a critical benchmark for the cryosphere. And this is really basically, in particular, when you look into the emission space, what does it mean that we need to do? What targets do we need to set? And what potential outcomes do we need to consider? That's really the message that's coming through here very, very strongly. There's another study that's currently under review, and I just want to highlight this because I've been talking about peaking, so let's talk about the long shot as well. And that's the question of Article 4.1 and achieving net zero greenhouse gas emissions, and what does it mean for crossing irreversible thresholds of the climate system. And even if we were lucky and we were on a 1.5 degree pathway, we cannot stay there. It is not safe. So if we stabilize warming around 1.5 degrees, there's a very significant risk that even that in the long run we would pass, or like we would trigger irreversible dynamics, in particular in the Western Arctic and Greenland ice sheet. So fortunately, the Paris Agreement as it stands built in some kind of a safeguard against that. So if we achieve a net zero greenhouse gas emissions as of Article 4, we would achieve long-term declining temperatures. And if this was the case, we would be potentially in there at the very left in a scenarios that peak warming just a bit above 1.5, and then achieve net zero greenhouse gas emissions, and then basically embark on a long-term cooling trajectory around 1 degree in 2300. And if we were there, we had a good chance to avoiding crossing such thresholds based on current knowledge. The uncertainties around this are very substantial, but this is a very, very strong and hopefully encouraging message of what we need to do, that even if we had a very limited overshoot, if it was really limited both in peak as well in time, and if we had a very continuous downwards trajectory thereafter, the risks of crossing some of the irreversible thresholds of the climate system could still be limited. All right, I want to close just with a little bit of additional advertising what's going to come from our side, so please stay tuned. We'll have a risk of overshoot briefing still coming out during that COP, but also a lot more also on the regional reports of overshoot and the implications for adaptation action, in particular also for two cryosphere regions. One is the Upper Indus Basin in the city of Islamabad, really relating to the questions of freshwater availability and supply from the Asian mountain towers, and the other one is the Arctic Fennoscandia with the city of Bodø in Norway, looking into all these questions there, also permafrost loss as well as glacier loss and everything else that relates to that. So we're not just stopping at providing physical risk, we're also trying to look at what to do about it, even on a very, very local level. And then we'll have an output tool, a climate service tool called the Climate Risk Dashboard coming out of the project. It's already alive and kicking, but we are still very much at the beta version stage. And in January, we're going to launch the version 1 of that tool that will also include cryosphere impacts for you to all explore. So stay tuned there, and I can only encourage you to follow us on social media if you like. Or subscribe to our email list, and I'm very much looking forward to our discussion. Thank you all. We have a little bit of a technical change now with the microphone for online participation, and then I'll hand over to Uta directly for her reflection. Sit here.
Yes, thanks, Carl. I will speak a little slower than you did. So yeah, I wanted to speak a bit more about irreversible thresholds, which are sometimes often referred to as tipping points, in the context of the cryosphere and the context of overshoot. So first of all, just a note on kind of the terminology. I'd already said sort of irreversible thresholds, often referred to as tipping points. And I think what's very important in this context is to be very clear about kind of the terminology to use. And especially in the policy context, to be very clear about what you mean by different tipping points, also since this concept is being used also in the policy sphere. So yeah, maybe on the physical science side, first of all, as you may know, the IPCC has generally assessed that the risks of crossing such tipping points or thresholds overall has been assessed to be occurring at lower global warming levels than previously thought. So the risks of crossing these thresholds has kind of increased. And some key elements in the cryosphere, which are assessed to have these kinds of threshold behavior, are of course the ice sheets, then mountain glaciers, permafrost, and also Arctic winter sea ice. So these are important to consider here. And one other thing, also an emerging area of research, is kind of that of tipping cascades. It's when different tipping elements or elements of the climate and Earth system are linked and can kind of, one element can influence the other when they cross these thresholds. One challenge kind of in the policy sphere is that it's kind of that of timescales. And we've heard a bit about this already. So especially, for example, ice sheets have behaviors on very long timescales, also influence sea level rise on very long timescales. And this kind of stands in contrast to kind of the shorter timescales that are relevant on the policy, in the policy sphere, which is more going from years to decades. So that's kind of a challenge to address in this kind of discussion around thresholds. So another important thing to note is that the crossing of these thresholds often refers to sustained warming levels. So a peak warming is not often sufficient to trigger this kind of tipping behavior. But, and that is the topic that Carl has talked about, an overshoot could already trigger such threshold behavior. But that is subject to a lot of uncertainty and depends also on the system in question. So there has been research which says that it's very important for temperatures to return below 1.5 in order to avoid the crossing of thresholds, for example, for the Greenland ice sheet. So even there, an overshoot would possibly not be sufficient to trigger such threshold behavior, but it would still have significant implications for sea level rise. So even there, it's important to limit overshoot to as little and as short as possible. Carl has already indicated this. It's crucial to take kind of a precautionary approach because from different emissions pathways, they have a risk of higher warming. In general, I think the sort of the headline kind of mitigation messages definitely hold also for these thresholds. So Carl already said it, peaking global greenhouse gas emissions before 2025, halving them by 2030, the mitigation of non-CO2 greenhouse gases such as methane is also crucial. And just to limit overshoot in terms of duration and also the magnitude. One other topic I wanted to talk about is carbon dioxide removal or CDR, which the IPCC has also said is necessary in order to achieve kind of the climate and the temperature mitigation goals. But what's important to note here in terms of overshoot is that delayed emissions reductions now cannot necessarily be compensated for by later CDR deployment, because if you have an overshoot and then bring temperatures back down, for example, through CDR, then risks of crossing such threshold still increase because such an overshoot could already trigger such threshold behavior. So that's kind of important to note in the context of CDR and these thresholds. And then, of course, tipping behavior or threshold behavior has important implications, of course, for adaptation, for reaching adaptation limits, for loss and damage, also crucial in the context that we're in here. Might also have security policy or geopolitical implications. So lots of things to consider here. But I think what's very important to note is that whether there's tipping behavior or threshold behavior or not, the messages are still the same in terms of stringent mitigation, adaptation, loss and damage action. And even for some elements that might not turn out to be tipping elements or threshold elements, such as Arctic summer sea ice, for example, it is still, the loss still is significant implications. So the messages kind of on mitigation adaptation hold also for these. Maybe that's stop.
Great, thank you very much, Lisa. And now we turn to Fabien Moisson, who's a professor for glaciology, I believe, and one of the leading glacier experts. Thanks for joining us, and I'm happy to hear your thoughts on this.
Thanks also for presenting these results, Carl. So my perspective here is that I have not much to add to the graphs that we have showed, except that perhaps going beyond the curves, which are very abstract somehow. What strikes me in my communication with the general audience, the media, is that the understanding of the time scales is what's missing when we talk about the cryosphere, because a lot of the loss is already locked in, and it's especially true for the mountain glaciers, which I'm working with. So these ice bodies in the mountains of the world, a very little understanding of the loss which has already happened, because basically we have put the ice cube out of the fridge and it's melting in front of us. So that's one part, which is the negative side of the message, is that if I talk to politicians, for example, in Austria, where I used to work, this understanding is not there. There is always this, we can save the glaciers and they are going to be in the Alps, perhaps even if we manage CDR and negative emissions somehow, or if we manage to cool the planet again, they are going to be there. But the timescales do not allow for this, and I'm seeing myself explaining this over and over again, and I think it's really something we have to repeat over and over again. The timescales at play in the Alps, glaciers are almost already lost. The differences between 1.5 is a little bit of ice remaining. Above that threshold, almost no ice left in the Alps. But in high mountain Asia, the graphs that we have chosen to highlight today, the ranges of outcome are huge. Between 1.5 degree, over 50% of ice remaining, and a few degrees more, it's almost no ice left in high mountain Asia. And then the second part that we are highlighting for the first time here is that then the time that it needs to grow back, which even in lay terms can be very easily understood, is there is a physical limit to how much ice we can put back on glaciers. It's the amount of snow that falls on them. People that go on the field in glaciers, and we have one of these images at the Cryosphere Pavilion, they measure more than 10, 15, 20 meters of ice melt at the snout of a glacier each year. To add this amount of ice in a single year at the top of the glacier, you multiply this by 10 times the amount of snowfall that we would need, and just the numbers don't add up. Glaciers need more time to grow than they need to melt. We have seen this in the history of the climate system. It's the same for the ice sheets. So this is also something we need to really imprint, is that all emissions lead to ice melt, which is going to be irreversible for centuries afterwards. So I think the project for the first time also shows this quite strongly and evocatively. So that was what I had to add to this.
Thank you very much, Javier. And now we are very happy to have Kaiser Kotonen with us. Kaiser is a senior policy advisor to Greenpeace International on climate change, and also very attuned to all questions around the cryosphere, as well as obviously the ongoing discussions here at COP. And we are very keen to hear your perspective of what some of these messages that we've been presenting today means also for some of the ongoing discussions here at COP28.
Thank you, Carl, and thank you so much for the very interesting presentation and the further insights we just heard. I plead guilty. I think it was perhaps 2005. I was, we had back this like van with full of stuff and placards and everything. We went to supermarkets around Finland. I'm based in Finland, Helsinki, Finland, but the land of snow and ice. We went to supermarkets. We had a campaign, stop warming to 2 degrees. So for years, we campaigned on 2 degrees, but I'm not the only guilty one. I mean, I still remember we went to Paris and the EU, wasn't it the EU pavilion that had this massive 2 degrees? That was 2015, and the world was still focused on that's the benchmark we need to meet. But there's also the hope. We went to Paris, and I don't think anybody really believed that we would come out from there with the very strong focus on 1.5. And then the IPCC report that came out a couple of years after changed everything. And there is a better understanding of how much faster we need to do everything. So coming to this COP, I think I wasn't the only one being a bit skeptical about, we're calling for fossil fuel phase out, which is the absolutely necessary thing that needs to now happen so that we can get that peak, we can get that halving of global emissions by 2030. But now already after this week one, I feel like we've moved so much from last year. There is more. I think I'm optimistic that by the end of this second week of COP, it's still very confusing because the weeks are not weeks. We will come out with a result that is better than countries expected they would be agreeing on here. But it does require you guys to be very strong with all these messages about what is the massive difference already between 1.5 and 1.6 or 1.7 and the overshoot. And the challenge there is indeed, like you said, that we need to be clear on the terminology. Overshoot doesn't translate that well into many languages. Like I wouldn't really know how to explain it in my language. So we need it in the science sphere, we need it in the policy sphere, but we need to then be able to explain, that you want to just stop any further warming as soon as possible. And then you want to make your absolute best to try and get, below the warming levels again. And yes, we will be needing removals, but I guess my country is a key example of why you shouldn't count on them, because we've had quite a lot of carbon sink, land use, for a long time. And Finland has one of the strongest climate targets among the industrialized countries, net zero by 2035, and going net negative after that. So we have actually net negative already in our legislation. The problem is that while emission trading sector emissions have been coming down, the sink has been decreasing, turning from quite a big net sink into a net source. So taking care of the removals then means taking care of the existing removals and enhancing natural removals, and not only waiting for the technical removals that we will perhaps have at some point, like BECCS and stuff, but really taking care of what we have now and building that ability, but not really counting on it. Instead, like getting to, zero emissions and fossil fuel phase out as soon as possible. So yes, from this COP, Carl will be lobbying for the peak by 2025. And I just told him yesterday, I can't get myself to do it because we've been campaigning for peak by 2015 when the IPCC fourth assessment report came out that said we needed peaking by, in Bali we were calling peaking by 2015. I can't get myself to do it because I want to have that halving by 2030. But you're right that we need the peaking first, but with the clear mind that if that's the signal we go out with from here, there's nothing to celebrate because the actual task is to get the 40% cut in fossil fuel consumption and use by 2030, which is going to be a massive task, but we're going to have to do it.
Great, fantastic. Thank you, Kajsa. And now we have ample of time for free-flowing discussion with all of us here, obviously the experts here on the panel, but also with all the experts in the audience. So feel free to just kind of bring your points, and we are very much looking forward to that. So just open the floor, and I'll be moderating them a bit, but looking forward to hearing your thoughts. Yeah, Urs, please.
Yeah. Thank you, foremost, first of all, for this great presentation and the good slides that you showed. I have two questions, like really technical questions. One is, first is, what is the sea level equivalent ice on the mountain glaciers? I know that like Greenland is maybe 7 meters and West Antarctica is about 4 meters, I believe. And what about the mountain glaciers? The second question is on the stability of Greenland and West Antarctica. And Carl, you mentioned the 1+1 degree by 2300 would be a good target. How certain are we that this is a good target? Because I read or heard that Greenland already is by 1/3 out of its mass balance today, right, and at a possible degree warming.
You want to go on the first one?
I'll go on the first one. Yes. So mountain glaciers have, our best estimate is about 33 centimeters of sea level equivalent left in them. So for the sea level rise, for the future sea level rise, if the big sleeping giants are actually going to melt, the glaciers are going to matter less in comparison.
Glaciers around the Antarctica.
Yes, that's yeah.
And there's also a lot of mountain glaciers around the
Yeah.
So, I mean,
Not including the mountain glaciers in Greenland and Antarctica.
Yes.
Yeah.
if you all they're not connected to the ice sheet, they're glacier.
Right, yeah.
Roughly 40 centimeters.
Yeah.
But about, I mean, the thing I use is about half a meter total, but we've lost already about 10 centimeters of that.
Exactly.
So,
And
Including those that are not really glass sheets.
Right.
Because there's really a lot of ice. Roughly 38, 40, 39, 37.
In addition to
Let's say orders of magnitude less than the big ice sheets. They have been, however, the one of the main contributors over the past sea level rise because they respond faster. So I was focusing on the time scales. Glaciers are like decades, and the ice sheets needs even more time. So the time scales of melt are, however, faster than the ice sheets, and in the past they have contributed quite a lot to the sea level rise over the 20th century.
Yeah, and maybe to pick up your second question, I think one of the biggest challenges around this is obviously that we do not know either how fast these systems do respond, and yet if we are really having a good enough understanding of what all the drivers that are going to potentially lead to such an irreversible loss, how they're going to react to different pathways of climate change. And I exemplify this in the case of the West Antarctic ice sheet, also with a cautionary note. So what's happening there is that we basically have marine melting. We have a marine ice sheet, and we do have hot ocean waters basically approaching the ice sheet, melting it. It's a process that we have very little observations about. It's very, very complex to model. This is happening under sea cover. So, like, we really have a very limited understanding even what's happening there right now. We also don't really know how much heat is already kind of in the ice sheet per se, but we really have basically an ocean dynamic process that we don't understand very well, that we also need to model at very, very high resolution, because you really need to basically model these processes around the ice sheet. And you need to connect it to some global response. So having said that, obviously we may or may not have already approached or crossed some of these thresholds potentially. We cannot rule it out, at least. And in a second step, we might not exactly know how these ocean currents, for example, are going to respond to an overshoot trajectory. So one thing I haven't shown you is that if you look at the Atlantic meridional overturning circulation, we expect a rebound on an overshoot trajectory. So if you had a weakening now, which would potentially now in relation to Greenland would lead to a rather basically cooler surface or like subsurface waters around Greenland. If you're on an overshoot trajectory, you might, like modeling results now indicate, you might see a pickup of that again. So you actually might not see an actually effective reduction in those drivers the same way you would just basically just tune the knob. So it's one of the other things where overshoot and overconfidence in overshoot might come back to bite us, because we might think, oh yeah, the declining temperature, so now all these systems should basically, the forcing on them, is under control. It might very well not be, and some of these dynamic responses might come around to increase risks of those again. So I'm not advocating for 1 degree being a safe threshold. I just wanted to point out that in our current understanding and modeling, we might be able to very effectively reduce those risks. But there's I think a bigger point to make here, and that's one of basically precaution, also in our ability to draw down temperatures in the long run. Because if our understanding will evolve, and it will over the years, we need to be able, and we need to leave ourselves also the possibility to react. And that's very, very important when we talk about discussions that we also have around here about abated and unabated and carbon dioxide removal and so on. We might find ourselves in a world where we need significant amount of carbon dioxide removal to bring temperatures down again, not to make up for remaining fossil fuel, not to make up for excess emissions that we could avoid easily. It's not an out of jail card to continue the ways we're doing. It is probably a very important and urgent stopgap measure. And if we squander the opportunity to use it for that, we might find ourselves or future generations in a very, very, very difficult position. So if anything, this is basically calling for precaution and a preventive capacity to do something, not to waste it on things where we could reduce emissions and so on. So it's an open question. I don't know where we need to go. Paris provides us with upper limits. It doesn't provide us with a safe level. And I think as science is evolving, we need to understand where we would want to go and what safe levels could be. Just to give you one number for this discussion, if we stabilize warming around 1.5 degrees for centuries to come, we would look into a long-term sea level rise of around 2 meters without necessarily crossing some of these major thresholds. So we know we don't want to stay there, but we don't know exactly where we would need to go.
Thank you.
Yes.
Really interesting. Thank you very much to all of you. I've heard you mention precautionary approaches and principles and ideas. It's the first time at this COP I've heard that phrasing, and any of the COPs I've been to. Now, I don't know whether I've just missed it in the negotiations or whether it is missing from the negotiations. So my question is, do the parties at these COPs in general, do we feel like they're taking a precautionary approach? Yeah. That's the question.
Not really. I mean, if I was, for example, looking at the latest IPCC report and reading it through the lenses of precaution, then I would go for the pathways that decline the fastest and bring the most sustainability benefits and limit the overshoot. So it would be, for example, in the latest one, it would be the LD type of pathways. And those are not the kind of pathways that are brought into these discussions. Here, it's kind of, let's be careful that we don't do too much. Let's go with the kind of median values, also from the IPCC science. And I think that's where actually we, in the civil society, we need the help of you guys and scientists, help policymakers to navigate, for example, the IPCC report, because the median values from certain category pathways are not necessarily the ones they want to follow if they actually understood what's behind those numbers, right? But it's I mean, you open an IPCC synthesis report and you try to identify what is it that I need to do. As you all know, it's not that easy because it's complex text for policymakers. So yeah, I think there's definitely a need to help policymakers to understand, if you wanted to follow precautionary rules, what would it mean in light of science? And how would you then need to interpret like different timelines, for example, when it comes to fossil fuel phase out or the reliance on abated.
Yeah, just to add, the 1992 convention includes the mention of precaution as one of the key approaches that should be taken to the climate crisis, including also explicitly highlighting that precaution shouldn't, like that uncertainty shouldn't hinder or shouldn't be an excuse for inaction. So it is there in principle, and if you haven't heard it, it's certainly something that's concerning. But these messages are even like, it's not just precautions, not that we don't know that these risks exist. We do know they are very much there. We can increasingly quantify them. So it is, it should be ever more basically on our lips to ensure that these messages are being understood. Thank you.
I'm Robert Gibson. I'm an accountant from Hong Kong. I fully agree with your messages. This is what needs to happen. Can we talk about what is happening? So James Hansen and other scientists have put out a paper starting to talk about global warming in the pipeline. And have been looking at it and trying to understand. One of the things that seems to have happened in the last 20 years, the rate, Earth's energy is imbalance, so the rate at which planet is taking up energy has doubled. And it's partly due to greenhouse gases, it's partly due to the raw area. We've got less white surface from film ice, so our albedo is changing. And then the ships, they stop burning heavy fuel oil. And so the aerosol effect reduced. And so we've got a doubling of the rate at which we're taking in energy. And it looks like we're going to be 1.5 degrees next year. The midpoint from Hansen's projection is we're going to be 2 degrees, midpoint, 2 degrees in 2040. So if that's what's going to happen, what hope is there? What from the point of view of the cryosphere, what can be done to save some of the ice?
I think first and foremost, we need to make sure that we embed this in our understanding of the scientific evidence. And James Hansen is obviously one of the founding fathers of climate science and a fantastic scientist. Yet what he's putting out there is not agreeing with our best understanding of our changes in radiative forcing, and particularly not on the question of aerosols. So a lot of his claims rely on the assumption that our understanding of aerosol forcing is insufficient to constrain it. It's not quite the state of play as we understand it in the context how it's been assessed in the IPCC assessment report. So we do have a handle on those issues. We do understand what's happening. We also understand what's happening now. We need to take these concerns very seriously and need to see how to relate to them. But we must not necessarily jump to the conclusion that this is the correct assessment, and what hundreds of scientists, including leading experts on this particular question, have assessed in the IPCC 6 report is therefore awfully wrong. So I think we need to be a little bit cautious. Our best estimates to date and make an estimate that under the current rate of warming, we might pass in the current policy scenario 1.5 degrees somewhere in the mid 2030s, and be on a rate of around slightly above 0.2 degrees of warming per decade. So I think that's important to appreciate, and also to appreciate that as a result of this, it's us who are very much in control of the global thermostat, and the best available science as assessed in the AR6 assessment report has very much shown that. So I think limiting to 1.5 is still definitely within reach, and I think we need to double down on our efforts to do so, and obviously need to be concerned about potentially much higher outcomes being a distinct possibility, but it doesn't take away anything from the key message that we need to reduce emissions now and in this critical decade. Thank you.
It strengthens the message.
If anything, strengthens the message. Yes.
Can I ask something?
Yes.
I think it was perhaps 2005 that we took a couple of scientists with us on our ship. Arctic Sunrise, I think, was the ship. We took them to Greenland to help them do their measuring. One of them was Gordon Hamilton, and like he really made an impression on me and his study. And what I learned back then, 2005, I think it was 2005, was the mechanism with which Greenland ice sheet melts. That is not just the surface, and not just the areas that touch the seawater, but it's the fact that the meltwater gets between the ice and the thingy and the ground, and makes it flow faster. And that to me was like truly an eye opener, and the realization of how much faster the glaciers were like flowing back then. So we took scientists to Parliament and wanted everybody to know this message. And then in 2000, when the fifth assessment report came out, that was another whoa moment, because there the message was that in just 10 years, the speed of a melting had increased like 6-fold. And I thought that at the latest would be an eye-opener for everyone, like how serious it already is. But by the time we got the latest report, people are already like, yeah, so what's new? What's new about Greenland? Did we lose it already? Like, is there anything to do to stop? It comes back to the hope. Like, we've been warned about Greenland for so long time already. What is it that the scientists, what is it that the policymakers should really understand about? Like you said, that it's really difficult to understand the timescales. And I think this is part of it. Like, it's difficult to understand where we are today compared to where we were, for example, 10 or 20 years ago, in terms of our understanding of the Greenland ice sheet behavior and how much have we already committed to. So can you, with this very long introduction to my question, if I went to my minister tomorrow and I wanted to bring one message about, the status of the Greenland and West Antarctic ice sheet, and to motivate them to act on 1.5, how would you pack it?
Yeah, good question. I think that's the kind of question that everybody asks themselves, and how they communicate with, their friends, family, at work. I think maybe one message is that, yes, our understanding of the risks has improved, and of threshold behavior, but not just that, but the mechanisms in general, but also our understanding of what we need to do. So, I mean, that's only strengthened the need to reduce emissions out by 2030, etc. Our understanding of the mitigation measures that we have available. Yeah, we know they work. They're developing, and we have this great assessment from Working Group 3 that shows us that they're available. They can close the emissions gap. They're cheap, and that's only only going to develop further on that path. So we know more about adaptation. We know more about what works, what doesn't work there. So I think, yeah, the knowledge in general has improved, and so what we know, what we need to do is only further underpinned by the science. And so maybe that's a message.
So let's say what we know today about the tipping points related to Greenland and West Antarctic ice sheet that we perhaps didn't know 10 or 20 years ago. Like, what should motivate us to understand the tipping points better? Or how should we communicate the tipping points related to this?
It's that our knowledge of them has improved. There still is uncertainty around them. So again, you talked about the median, and you talked about the median before, and that is an important kind of kind of point to communicate, but also that there is an uncertainty right around it. So I think, yeah, we only know more about it.
address that? I'm
Yes,
gonna channel ice sheet scientist now, okay, this is.
Yes.
So what we have learned even since AR6 is that the IPCC report, even AR6, it has a median. But then it has a dotted line. That shows the potential for much faster sea level rise. And the reason they did that was because there were only 2 studies, but they felt they were good enough that they wanted to include that dotted line. Since that came out, there has been several more studies that have come out and they point to the dotted line, which means that the ice sheets will respond sooner, faster to lower temperatures, and and then this is where the uncertainty, that I would use the word risk, because uncertainty makes it sound like it could go either way. It's trending towards those higher levels if you take into account ice processes that we're just beginning to understand. But over in that room, we probably have a paleoclimatologist who will say to you, of course, because we know that in Earth's past, for example, at 2 degrees, the stability sea level rise is 12 to 20 meters, right? So it makes sense from their point of view that maybe these, come into play sooner. And then the question was rate and time.
Right,
Yeah.
thank you very much. That's interesting to know that the dotted line is already stronger.
Unfortunately, the dotted line is a little bit less.
Yeah.
Not only, they had some things, not only the dotted line is the future, there's uncertainty, but what has really changed, there's a lot more observations now of massive retreat of grounding line, massive mass loss, massive thinning. So it is almost impossible, and we know a lot more about the back topography. It's very slow. It's like if the planar retreats into a deepening of the ocean, it's when ice hates water, it becomes unstable. So that is definitely a lot of really observations of mass loss, retreat, thinning, and so it's sort of doomed. So only the matter of the question is when. Which is thousands of years or hundreds of years.
And finally, because I found always like these new feedbacks which have been discovered, and I mean, we are doing our best, but the more we look, the more positive feedbacks we see. The only, if I'm thinking about my field of research, mountain glaciers, the only negative feedback we know is that glaciers are retreating to high areas and are therefore melting less. But everything else we know about are positive feedbacks. And I think the Paleo archive is also telling us a lot about these positive feedbacks in other elements of their system. And then my worry as a scientist is not that we don't know about them, is more that they are not included in our projections. And like if I look at the last 2 years in the Alps, where we lost so much ice in 2 years' time, and we look at our model projections, they are not as negative as we have seen. And that's because we simplify the process to a way that these positive feedbacks are not included in enough. So I'm not sure the politicians are really listening to that the right way, but basically we know about them, and the question of the amounts is perhaps a little bit like a detail, but yeah.
Yeah, but since we had a lot of perspectives, also happy to add mine. I think the key question is that we link urgency to legacy, because what we are talking about is a legacy of actions, and these legacies are going to be around for centuries to come. And make no mistake, if the Roman Empire had burned fossil fuels, we might not know Roman emperors or whoever decision makers were around for their do's or don'ts, or which part of Europe they conquered or didn't, but we would know them because our coastlines would still change because of their actions. And if you talk to a policymaker, you would clearly know the coastlines of this world and the cryosphere of this planet going to change for centuries to millennia to come, depending on your decisions today.
Yeah.
And that's the legacy of what you are deciding here. Yeah. And that's the message that you're going to understand, that the history books will, your constituency might forgive you for whatever you do or don't. History books won't.
That's a good
and the cryosphere response is writing the history book. And right. This is physics. This is nothing you would do about. You cannot revert those physics. You are locking in a legacy, and it's the legacy of your inactions. So that's, I think, becoming ever more clearer that this is very much where we are. And then this needs to be coupled, obviously, with a message of action. And that is that if you act now and you act decisively now, we might be still able to avoid the worst. So it's down to you to do the right thing. And if it turns out, if you don't, then we definitely know where we are going.
Right. I'm impressed.
Anyways, have maybe one more question, or we probably bring it to an end slowly. But I want to thank you all for this fantastic discussion. I want to invite you all to give a big round of applause for our panelists. And big thanks again from the Provide project to Pam and the whole team from the Cryosphere Pavilion for hosting us and for giving us the opportunity to build our results and have this discussion. And I wish you all and us a very successful COP. And I hope Kaisa is right in a hopeful assessment. I certainly look forward to see those outcomes coming through over the rest of the second week. Thank you all.